Hi, algebra students. We're going to start a new unit today. It is chapter 8. It is on linear equations. We're going to start with a review of graphing on the coordinate plane. So there's a list of 5 terms that I want you to pause the video and try to fill in labeling on your graph below. And then you're going to unpause the video and check your answers with mine. So here's what I want you to have labeled on your graph. The first thing being the origin. The origin is at the ordered pair 0, 0, and it's in the center of your axes, x and y axes. And the thing to remember is that we say in the English language, where do you originate from? That is asking where do people come from, and you are always graphing ordered pairs from the origin. So that's where you should be putting your pencil before you plot a ordered pair. The next thing is I also went ahead and labeled for the x-axis, it is horizontal, and the y-axis is vertical. You'll need to know that vocab later on when we talk about slope, so it would be good to also label on your coordinate plane. The next thing, and I labeled it in red, is the quadrants. We usually use a capital Q and then Roman numerals, but Roman numerals can get a little confusing sometimes, especially when you get to the fourth quadrant, because it is really the Roman numeral for 5 is a V, and then we're saying 1 away from 5, so we're saying actually 4. To remember these, you can remember that they start in the upper right hand corner and make a C, and I just kind of remember that the order just goes 1, 2, 3, 4, and I just remember C stands for coordinate plane. It's kind of a dorky way to remember that. And then the last thing I wanted to review with you guys is also I wanted to talk about ordered pairs. You should know that an ordered pair is always an x value and then a y value. And depending on whether it's negative or positive, that's going to determine which way you're going. So if your x value is positive, you're going to the right first. If it is negative, you're going to the left. If your y value is positive, you're going to go up. And if it's negative, you're going to go down. These should all be things that you're familiar with. The one thing that I wanted to make sure I labeled on your ordered plane with you guys is the common mistake. When you get an ordered pair like 0, 5, a lot of times students will forget whether you're going to the right 5 or whether you're going up 5. So remember, you're starting at your origin, and for the ordered pair 0, 5, you're not going, your x value is 0, so you're not going to the left or to the right at all, you're just going up 5. So 0, 5, go ahead and mark on your ordered on your plane is up 5 on the y-axis. And if I give you an ordered pair something like -2, 0, that means you're going to the left 2 and you're not rising or falling at all. So the ordered pair 0, 2 would be on the x-axis, 2 to the left. So that's -2, 0. The last thing that I would like you to mark on your coordinate plane before we move on from this brief review of what you learned last year in terms of plotting is, and I cleared off the whole graph so that you could see this, is a list of just the x and y values of the points that you can expect in each of the quadrants. So starting with quadrant 1, which is the upper right hand corner, you should be looking for x values that are positive and y values are positive. But keep in mind, this does not include necessarily points that fall on the x-axis and on the y-axis. So we're just saying points that are in the middle of that quadrant. Moving over to quadrant 2, you should be looking for x values that are negative because you're going to the left from the origin, and y values that are positive. They're still above the y, or the 0 for the y. In quadrant 3, you are anticipating x values that are negative and y values that are negative. And finally, in quadrant 4, you should be anticipating x values that are positive and y values that are negative. Moving on to example 2, I want you to take a look at this. This is a little bit different than the equations that we've been looking at so far this year. This is called a linear equation, and the reason is its graph should form a line. And the way to tell whether it's a linear equation is we're going to use two variables, both y and x. And before you panic, I'll show you exactly how to deal with that. So for this example, I want to make a table of 3 solutions, and I want to find 3 ordered pairs, and then from those ordered pairs I'm going to go ahead and plot it. So you'll see that I've filled in the x values already for you. We're going to plug and chug with x values of 2, 0, and -2 and find the y values that go with those to plot. So all I'm looking for in this middle column is basically your workspace. So what we're going to do is we're going to take the x value of 2 and we're going to plug it in for x into my equation. So I'm taking 2 times 2 minus 1. Following order of ops, you're going to see that 2 times 2 is 4, minus 1 should give me 3. So that is the y value that goes with the x value that we just plugged in, and we can write that as an ordered pair listing x, which is 2, and y, which was 3. So one of the points on our line of the graph of this linear equation y equals 2x minus 1 is going to be the ordered pair 2, 3. The next one I want to go ahead and plug in is 0. So I'm going to plug in 2 times 0 minus 1. That gives me 0 from 2 times 0. Minus 1 is -1, so the y value is -1. That's the ordered pair 0, -1. And the last one is -2. So 2 times -2 minus 1. 2 times -2 is -4, minus 1 is -5. So this is the ordered pair -2, -5. And I want to point out something. The reason I chose these points is we usually choose 0 because it's a nice value to plug and chug with. And we usually pick one positive number and one negative number, and I'll tell you when you need to be careful picking these values so that you get integer answers. But for this case, we just kind of picked 2 and -2. It doesn't always have to be those values, and I don't want you to think that there are only 3 solutions to this linear equation because there are an infinite number of solutions. You could plug in anything for x and find an ordered pair with y. Some of them will be decimal answers and fractional answers, and that's okay, but I'm going to teach you some strategies to avoid decimal and fractional answers for y and tell you how to avoid that. Now we're going to go to our graph and we're going to plot those 3 points. The graph is a little faded, so you're going to have to do a bit of estimation here, and when you connect your points, I want them to be able to be connected with a ruler. So starting with the first order pair, 2, -3, we're going to start at the origin. 2 means we're going to go to the right 2 and up 3 and make a dot. The next one we want to do is at 0, -1. This is one of those special ordered pairs that falls on one of the axes. Because 0 is for x, we're not moving to the left or to the right, but we're going down one block and making a dot, so that falls on our y-axis. -2, -5 is to the left 2 and down 5, and I'm going to plot that right about here. And then if you connect them carefully with a ruler, you should be seeing, for the most part, that looks like a straight line. And that's why they're called linear equations. They form a line graph answer. And the next thing I want you to see is that there are an infinite number of points along this line. So we only chose 3, but you could find an infinite number of points. So I want you guys to try to fill in the table here for this next linear equation, y equals -3x plus 1, you're using x values of 2, 0, and -2 again. Find the 3 ordered pairs, and then you're going to plot them with me. Okay, so check the values that you got for those 3 x values in your chart. You should be getting the ordered pair 2, -5. That means you're going to go to the right 2 and down 5 and make a dot somewhere around there. And the next ordered pair 0, 1 is going to fall on the axis. It's going to be no spaces to the left or to the right, but up 1 on the y-axis. -2, 7 should be to the left 2 and up 7. So somewhere right about there. And then you're going to connect those. It should look better than mine. And that's the graph of your equation. So take a look at example 4. This is an example of a table where we're going to be really careful with the values that we pick. If you look at this linear equation, we've got a fraction times the x values. We've got 1/3 times whatever x is. So I want to be smart and I want to think ahead, and I only want to choose x values that will give me integer answers, which means I'm trying to think about multiples of 3 that when I multiply them by that 1/3, I'm going to get an integer output. So that's why in your table you'll see the 3 values kind of have changed from the 3 values that we've been using. We're using now 3 instead of +2 and -3 instead of positive or -2. So go ahead and fill in your chart by finding these values for me, and then go ahead and plot. So I have my 3 ordered pairs coming out of my table, 3, 5, 0, 4, and -3, 3. And then my graph looks like this. Now, every year students get a little confused about 5 and 6, so I'm going to put those in red because these are really important to remember. If you want to plot a graph for the linear equation x equals -4, you'll notice that looks a little different than the other ones we did in examples 2 through 4 because it doesn't have 2 variables, it just has 1. So what you want to do is you want to go to the x-axis, which we identified on example 1 is the horizontal axis, the one straight across, and we're going to find -4 on that axis and make a dot. You'll notice there's no chart that's necessary for this equation graph because I just identified -4 on my x-axis. I'm going to draw a line that goes through that dot that is not the axis itself. So it's not going to be a horizontal line like that. We want to draw a vertical line through -4 on the x-axis. And that is the graph of x equals -4. Things to remember here, the axis and the graph of a just plain x equals, they're opposites. So the x-axis we talked about being horizontal before, this is actually a vertical line. And any x equals graph is going to be a vertical line. It's going to go through the x-axis at that point. So you can probably guess what's going to happen for example 6 when I ask you to graph y equals 3. You're going to go to the y-axis, make a dot at 3. And then you're going to draw a line through that graph that is not the y-axis itself. So it's not going to be vertical like that. We want to go horizontal this time through that dot. So the graph of any y equals linear equation is always going to be a horizontal line, which you can remember a couple different ways. You can just remember to graph a point on that axis and not go through the axis itself, or you can remember it's the opposite of our y-axis, which is vertical. So in examples 7 and 8 and throughout the rest of your packet, we're giving you kind of a shorter version of the table that we looked at for examples 2 and 3. I want to look at being able to plug in some x values to this linear equation y equals x minus 3 and then get the y values that go with it. So when you see a table like this, you don't need to show me your steps of work, but you should still be checking everything in your calculator. And like I said, it doesn't matter what x values you pick here, but obviously you want to pick things that aren't like -6.2. So I'm going to pick a negative. I'm going to go with -2. I'm going to plug in 0 and I'm going to plug in 2 for my x values, and I'm going to find the y values that go with them. So here I've got my filled in chart here. I've got -2, -5. So let's go ahead and plot that. To the left 2, down 5. So we're looking at quadrant 3. The second order pair was at 0, -3. So no left or right, just down 3. Make a dot. And 2, negative 1 is to the right 2, down 1. So my graph will look something like that. Now for this next example, number 8, you can fill in the chart if you want to. That's not really necessary. Just read this out loud as I read it. It says y equals negative 2x plus 1 is the ordered pair 4, negative 6, a solution of this equation. So all this is asking is, if you were to make a chart and you were to pick 4 for an x value, would you get negative 6? That's the question. And there's an easier way to do this other than plugging in the chart. You can realize that this ordered pair and every ordered pair should be x comma y. So if you look at your equation, y equals negative 2x plus 1, what I'm really doing is a check where I'm plugging in 4 for x, negative 6 for y, and I'm going to see if I get the same thing on both sides. So I've got negative 6 equal to negative 2 times 4 plus 1, and I'm going to solve on both sides. So when you solve this, you're going to get negative 6 equals negative 7 on the right side. Because those two values do not equal each other, the answer is no, it is not a solution of this equation. A solution would look something like if I had done all my work down to the bottom and I got something like 2 equals 2. So that would be a time when I would say yes. This case, no. On the next page, I'm going to ask you guys to go ahead and fill in the charts and to plot 9 and 10. The only thing I want to make sure you understand is that in example 9, that's an opposite of x sign, which was a little tough for some of you when you were evaluating because you forgot to take the opposite of a value. So if we're going to pick the standard two values other than 0, negative 2, 0, and 2, when you plug this back in, you're going to take the opposite of negative 2 for the first one, which is positive 2, minus 3 would give me a negative 1. So just be cautious about that. Example 10, I would recommend again that you stick with negative 2, 0, and 2 to find your 3 ordered pairs and then go ahead and plot them. So here's my filled in chart for example 9 and my graph. Go ahead and check with yours. And then go ahead and check example 10, my chart filled in, and then my graph. Before you pick values for example 11, I want you to take a look at this. You've got a negative 1/2 coefficient in front of your x value. So I want you to think about what values you should be plugging in for x here to make sure that you get integer answers. So you should be thinking that you want values that are multiples of 2 so that you can get an integer output there, and that means that you can use the 3 standard negative 2, 0, and 2. So there is my graph and my filled in chart for example 11. Try 12 on your own, and there's my filled in example 12. You'll notice that I didn't have any plus or minus here to the end. It was just 3 times whatever x was. And so my graph went through the origin. It didn't move to the left or to the right at all. And we'll talk about that when we talk about parent graphs later on in the year. Make sure that you're bringing any questions to your math teacher the next day that you see them for class. And make sure that you are watching this video again before quizzes or tests and doing all the practice that we ask of you during class.